Hi there, and welcome back to Ades Workshop. So we're going to get on with the Knurling project. Now, most of you will have noticed I've been putting an episode of this up pretty much every day, and that's unusual for me to, produce videos on that sort of basis. And the reason for that is that I managed to get a couple of days spare time and literally got on with it and filmed as it went along, and it left me with a big backlog of clips of the project so far. So what I did was, every evening, grab the pile of clips, put them together, edited, made a video, uploaded to YouTube. So that's why you've been getting one every day. So anyway, we've caught back up now, so I'm back sort of filming live. I'd imagine this one will go out on the Saturday morning, something like that. Anyway, I've actually done a bit of forward planning. Now, as most unlike me, as you know. I'll show you what I mean. So I did a little sketch, and plan A was obviously with my 20mm square bar to put the two flats, top and bottom, to make it the right width to go into the slot. And then a full radius on the end, what have you. Now, the overall width of this is 20mm. Now, if I just put a full 20mm radius on the end, we'd have fouling problems in the bottom of the slot. So move on to plan B. And I thought, well, we're going to have to thin the sides down to the same width as the length, so to speak, so that it didn't foul out when it was in the bottom. But I didn't think that looked very nice, so I went on to sort of plan C, where, as you can see, the from the radius, or from the what should we call it, from the tangent of the radius out to the full 20mm, I've sloped the sides out. So when it's in the block, the red line here is the red line here is the holding block. And obviously the circle in the middle is a dowel pin, and you can see I can get pretty close on the sizes. I'm going to come a mil back with this, face, and that should allow it to rotate upwards. It won't rotate downwards very much in this sort of direction, but then again, when it's parallel, I've worked it out with 3/4 knurling wheels so that it'll knurl 6mm or 1/4 inch bar. So yeah, I don't think I'm going to have to go much smaller than that. So yeah, a little bit of forward planning for a change, just to make it look nice, because, well, I'm the one that's going to have to be looking at this every time I use it. And if I don't, if I botch it up or make a rough-ass job, I'm sure it'll work. But if I make a rough job of it, I'm going to be looking at that and thinking, why didn't I do that a bit nicer? Anyway, so I think that's the best sort of look that I'm going to go for. So the first thing I got to do is, let's go back to plan A, is to mill the flat top and bottom so that it fits basically in that slot. Right, got a couple of parallels behind it, and you can see I've got a toolmaker's clamp on the back, and that's just to pull it hard onto the parallels when I tighten the vice up, or before I tighten the vice up. So I don't want to go hitting it to tap it down, because the worry is that you're going to move the vice out of alignment. Anyway, because this dimension in this way is the more critical, well, it is when I do the second side, but I want to take the same off both sides. So I know the dimension I'm aiming at. It's actually 16.7. So I'm gradually bringing it in, because I can control that with the carriage, until I get a measurement across there of 16.7. And then, because the slot is 14mm deep and I've only got a 12mm cutter, I'm going to have to move it up afterwards. So what I'll do is drop the cut back off, move it up to just touch the cutter on the underside, and then do the same sweep across at the lower point. So anyway, I'll get on with that. Okay, well, that's straight out of the lathe, and it does enter, but it just enters. I mean, as you can see, it'll stay, it's just entering. I think the final stages of that are going to be hand fitting. Bit of filing, bit of polishing, we'll get it to be just sweet in the groove. I've already given the inside of the groove, a good flat mount, make sure there's nothing in it. But yeah, that's going to be hand fitting the rest of the way. So that's one of them done. Just got to do the second one now. Little detail I forgot to show when I was doing the first one is I just, says he, just got enough room to get a mic in down the back of my parallel. It's just, I've had to pick this mic. It's not the best one I've got, but it reads accurate enough to get a finished size. So I'm on 13.45 at the moment, and I'm aiming at 13.2. So I'll machine that down gradually to 13.2, and then as it happens, quite an accurate figure. To get that 14mm shoulder, I'll release it, bring the part up to do it down to the line at 14. But if I set the calipers, and it's a nice round figure, so that the reading is 9mm, so you can see it's 12 at the moment. If I set the calipers at 9, bring it up to touch the calipers on a hard shoulder on the top, that machines it to within a thou or so of 14mm. So a bit of luck really, but yeah, it's a bit of a faff this way. Milling slide would be a lot easier for adjustments, because I can put the clock on it and, you know, adjust it on a screw, so to speak, rather than by feel. But at least the rigidity is superb, and I'm getting a good finish, so happy days. I keep saying happy days, don't I? Never mind. Perhaps I am having happy days. Better than sad days, I suppose. Anyway, I'll get on with it. So I've raised it up. Just cut the shoulder at 14mm. And I'm cutting half mil at a time. As you can see, it's a quick little operation. And I go right in until I reach the same reading on my DRO. And I'll stop maybe 2 thou from the bottom and keep having a look at it, and just single increment at a time on my DRO until I see the two surfaces blend together. But it's pretty much within and nothing on the DRO. Sometimes it's 0.02, sometimes it's smack on 0, where the two blend together. So we're not far off having both of these pieces completed as far as the, so that's leaving half a mil, as far as the thickness of this. So I think we're going to have to make up a bit of a jig, I think, to get the two holes in. I think we'll do something there, and maybe a bit of a button inside afterwards on the outer, like a little file guide, something like that. Right, that's leaving it 0.07 short. So from this point I'm going to turn the camera off because it's getting a bit more delicate. And I'm going to get in and have a close look at what I'm doing just to blend these two together. So I'll bring you back. What's the pair done? Hand fitting next. As you can see, they've entered probably a millimetre. And just to prove there's no cheating as to how good a fit they are. Yeah. Gravity's not taking over, and I can pull them out with 2 fingers. Okay, so a little bit of hand filing, fitting, just to get those sizes right, but I think what I'll do is leave them up for the time being while I drill the holes in the end for the pivot pins and file the profile on the end to shape. I think I'll leave them as they are because I don't want to damage the contact surfaces, or the finished contact surfaces. So what I'll do is, work out how I'm going to do the filing of the profile on the outside edges and drill the hole. So I think the next thing you'll see is me sorting out a method to drill the holes. Okay, so using his brother as a parallel, I got the sticky pin, and I'm working around the camera here, holding it against the fixed jaw. Just close the vise there. Oh! How does that look? Well, we're right on that centre line, so happy days for the one way. I'll get the wobble pin out, pick up the end, and plot the centre of the hole. Now, the centre of the hole is 6.75 was my magic reading to the centre of the hole from the outside edge. I'm going to reduce that just by, maybe 6.65, just to give a clearance on the overall length in the bottom of the groove. So 6.65 and on that centre height. So I'll pick up with a wobble pin, come in 6.65 and again drill and ream a hole 1/4 inch. No, not 1/4 inch. 6 mil. So I got a 2.5 mil ball on the end, which would give me 1.25, and the 6.75 is 8 mil. So as I said, I'm going to go just less than 8 mil. And speed proceedings up a little. Getting close. Just waiting for it to kick. Oh, there we go. Give myself a 0. Oh, yeah, bugger. And I'm going to do it again. Just to confirm. Right, should be there. Yeah, 0.02 on the DRO. Right, so there's my 0 mark. And I want to go, I'm going to go 7.9 millimeters. And then lock my cross slide. There we are, 7.9. I'm going to lock the cross slide and drill the hole there. Just had a double check of that, had a look. Sometimes if you've made a boob, best to just check before you go too far. We've got a little centre drill. Of course, the glory of doing it this way is that next time I've already got my 0 from the end because the fixed jaw doesn't move. All I got to do is set it on height and drill it through. But that's another story. Right. Oh. Badly prepared as usual. Let me get the set of drills I need together and we'll come back. So, having got hold of the set of drills, 5.1, I'll do the same method as I did on the other hole. Speed things up a bit. That's better. That's cutting beautifully. That's actually running at 1200 RPM there and cutting sweet. So you don't want to see me drilling a couple of holes, I'm sure. But I'm going to go in with a 5.8 and then a 5.9 and then a reamer, if I can wind the chuck the right way. I'm still doing it. And then a reamer, and then I'll probably just countersink this side. Go down a bit. Oh, that's sweet. Okay, yeah, so I'm going to drill out with the 5.9 now, then the reamer, and then we'll go from there. As I've got it up here, it may be worth putting the hole in the other end that takes the knurling wheels. I know I haven't done the slot for them yet. Problem I've got is the knurling wheels are 3/4 of an inch diameter, or 19.05. Anyway, we'll call them 19 mil diameter knurling wheels. So if I put the hole in the centre, the knurling wheel won't stick out the bottom. In fact, the block will rub the job before the knurling wheel. So I think I'll offset them. How much shall I offset them? I want them sticking out the bottom a good 2 mil. If we said 2.5 mil. So if I was to draw a line up 7.5, sticky pin it for height as normal, and then perhaps come 10 mil back from the end. I'll work out whatever that is from that hole to that hole. I can index across, do this one, swap them back over and do exactly the same on the other one, and job's a good one. I can offset them both low because obviously one will become the top, one will become the bottom, and the other one will just be the other way up. So my dimension between the two ended up being 44.25 mil. I've raised the block up 2.5, lined it up with a sticky pin again on the line at 7.5 up from the bottom. and we will put a 1/4 reamed hole in there. Might have to play with these sizes a bit afterwards. But yeah, so far so good. I'll do them both like this. I know the centres now, 44.25, and I know they'll both be exactly the same or near as damaged to what my DRO says is the same. So I decided to err on the side of caution, as I don't know exactly what size pins are going to be needed to go through the knurling wheel yet. I'm going to recycle the knurling wheels out of my old knurling tool. I've seen knurling wheels for sale on eBay. They say silver, whether that's silver, steel or what have you. You can buy very expensive ones which are high-speed steel, which is what I want, you know, for a long life. But I know that the ones in my knurling tool, which is again probably best part of, well, 40 plus years old at least, and I know that they are quality wheels and there's no damage to them. So I'm going to recycle those by bopping them out and seeing what the pins are. But I've decided, and I can't see the drill now because I pulled 2 out, 6.2. Okay, I've decided to hold off and just drill these out at 6.2 mil for now. On the grounds that I can always take more out, but I can't put it back in again. Well, not without bushes and what have you, but we don't want to go down that route. So yeah, I'm drilling them out at 6.2. And if they've got to be reamed at a later stage, I can always do it. Okay, so there are the 2 identical blocks with the offset down as I did them. Or in fact, as you saw it, it was more like that direction. So basically, that one was going to go there in that direction. And that one goes there in that direction, and the 2 offsets are facing each other, hence why it didn't matter that I did them both the same way. So the next procedure, I think, until I get the wheels out and what have you to see what slot width I want in the end, that sort of thing, I think the next procedure is going to be to radius and slope off the ends of these blocks. So I think what I'll do is, yeah, I'll make up a couple of rings with a bolt through them of the diameter of the radius, and I can use those rings as a file guide for when I'm filing the end in up to that point there. So I'll knock up a couple of rings. I mean, it's only a simple turning job. They're basically a thick, like a thick washer. And they're going to be, what, 6.75, so they're going to be 12, 13 and a half, or maybe slightly under 13 and a half diameter. Maybe 3-4 mil thick, 6 mil hole through the middle, and I might even whack a dowel through the 3 of them, put one either side, and that'll be a file guide, because I'll have the radius there, and I can file to it, or dress to it, or polish to it, however you want to call it, to get the nice radius on the end. But that's hand fitting, but it's always useful if you've got something there as a guide rather than just a line, because you'll find when you hit the bush on the end, which probably I'll make so that it just rotates, when you hit that with the file, you know you've gone to depth. So it's easier than doing it by eye. On the same note, I could drop the guides inside here with a spacer between them and use the same ones, because it's the same sizes, to put the radiuses on the outside of this. Oh well. So I'm going to throw these couple of clips in at the end of the video of this episode. It is to do with this job with the knurling tool, and it is a tool to do something. So the first clip is, I'm just putting a flat face square to the world on this piece of aluminium. It's bouncing around a bit, I got a bit of a heavy cut, but I'll take a gentle lick across the top in a sec. So that's the first job, is a flat square face to the direction of rotation of the spindle. So I'll throw another clip in So, having faced it off, I'm going to drill and ream a hole, not all the way through, 20mm deep. Same procedure as before, 5.9, and then finish it off with a 6mm reamer. So that dowel fits in there nicely. Okay, the question is, what am I making? All will be revealed in the next episode. There we are, guys. I left you with a bit of a teaser this time. Thanks for watching, thanks for subscribing, and we'll see you all very shortly with the answer to the question.